All right, imagine this. You're on a farm, breathing in the fresh air, feeling the sun on your skin, surrounded by fields of fresh green alfalfa stretching as far as the eye can see. It's a vibrant, living carpet. Cows are happily munching away, their jaws working rhythmically as they enjoy their meal. They seem content and peaceful. And you're handed a challenge. How do I actually measure the amount of milk these cows produce over time, with accuracy and efficiency? Especially if their milk output changes every hour, fluctuating with their feeding and rest cycles. It's a dynamic process. That's where integration steps in, offering a powerful solution to this complex problem. It's not just some abstract math thing you learn in a classroom. It's a superpower for tracking stuff that changes, like lactation volume in dairy animals fed with alfalfa. It allows us to understand the nuances of milk production. Let's connect the dots between calculus and cows and see how these seemingly disparate worlds intersect. Picture this. The rate at which a cow produces milk isn't constant. It's a variable that depends on numerous factors. After a fresh meal of alfalfa, rich in nutrients, her lactation rate might spike, showing a clear increase in milk production, then slowly drop as time goes on, as the effects of the meal gradually diminish. Mathematically, I can call this rate RT, where T is time in hours, giving us a way to quantify the milk production at any given moment. Now, if I want to know the amount of milk produced over, say, one day, a 24-hour period, I don't just multiply the rate by time because the rate keeps changing. That would only give us an approximation, not the precise value we need. Instead, I use the definite integral, a tool that's perfectly suited for handling these kinds of dynamic situations. In symbols, the total lactation volume phi over a time interval from t equal sign A to t equal sign B is V equal sign from A to B of RT dt. This formula represents the accumulation of milk production over the specified time period. Let's say, after eating alfalfa, the cow's lactation rate follows this equation, a simplified model to illustrate the concept. RT equals sign 2 plus sin PT12 liters per hour. This equation gives us the rate of milk production at any time t. The 2 is the baseline, representing the cow's average milk production, and the sign part models those tasty spikes after feeding, adding a layer of complexity. To find out how much milk she produces in 24 hours, a full day of lactation, I set up my integral V equal sign from 0 to 24 of 2 plus sin PT12 dt. This is the mathematical expression that will give us the total milk volume. Don't worry, if this looks scary, think about it like adding up lots of tiny changes in milk output, hour by hour, all day long. It's a process of accumulation. Integration gives me the sum of all those little bits, even when the rate jumps around, providing an accurate total. So next time you drink a glass of milk, remember, behind every drop is a mix of biology, the natural processes within the cow, farming, the careful management of the land and animals, and a dash of calculus magic, providing the tools to understand and optimize the entire process. Integration isn't just for textbooks. It's the secret math behind real-life problems. From fields of alfalfa to your breakfast table, connecting the farm to your daily life. If you want to see how this works with real numbers, try plugging that function into a calculator or graphing app. Experiment with different values and see the results for yourself. Watch the area under the curve add up, and you'll see exactly how integration tracks every drop, giving you a visual representation of the milk production process. Stay curious, and maybe thank calculus for your next milk mustache. It's a testament to the power of math in our everyday lives.